Suppose you're baking brownies. Coming out of the oven, they're pretty hot. If you want them to cool off faster, one thing you can do is cut them into pieces. But why does that work? Whether the cake is in one piece or in multiple pieces, it contains the same amount of mass and internal energy. But cutting it into pieces creates more surface area, and the heat energy leaks out through the surface. So with a greater surface area, you have a greater rate of heat leaking out, so the whole mass will cool off faster. Let's look at this in a more general way. If you have a sphere of radius 1 and double the radius, all aspects of that sphere get bigger. The diameter is now twice as big, but the surface area, given by 4 pi r squared, is now 4 times bigger, since it depends on the radius squared. And the volume, given by 4/3 times pi r cubed, would be 8 times bigger, since it depends on the radius cubed. So 2 times 2 times 2 is 8. Doubling the size of a sphere increases both area and volume, but the volume increases more than the surface area. Compare the volumes and areas of differently sized spheres. As we go from radius 1 to 2, and so on, both area and volume go up, but volume goes up faster. For small spheres, the surface area is greater than the volume, but volume quickly catches up and overtakes surface area. So you can see that small objects generally have more surface area than volume, while large objects have more volume than surface area. This is why it takes 10 to 15 minutes to bake cookies, but 30 to 40 minutes to bake a cake. Cookies are small, and so have more surface area than volume. Therefore, they will absorb the heat from the oven quickly, and their small volume means that there isn't a lot to heat up. Cakes are large, and so they have more volume to heat up than surface area to allow heat in, making them take longer to bake. And the same geometry also means that when you take them out of the oven, cookies will cool off faster than cakes. How does this relate to planets? Planets form when a bunch of smaller planetesimals smash together. Each of those individual collisions releases heat. So when a planet first forms, it is very hot all over. But once it's finished forming, it starts to cool off. The heat can only be released via its surface area, and so the surface will be the first to cool off. So out of all these differently sized planets, which one is going to be the first to completely cool off? The cookie or the cake? The smaller planet will cool off first, due to its larger surface area to volume ratio. The larger planet, with its larger volume and not as large surface area, will take much longer to cool off. Applying this to the 4 terrestrial planets in our solar system, Mercury, being the smallest planet, cooled off first. The next biggest is Mars, which cooled off next. Then we have Earth and Venus, the largest of the terrestrial planets, which have solidified on the outside, but are still warm and gooey on the inside, much like the perfect chocolate chip cookie. Because of their large size, they are still very hot on the inside, and it's going to take a long time for all that heat to escape. In the meantime, that internal heat helps drive geologic processes, such as active volcanoes, which are absent on Mercury and Mars. Note the difference between internal heat and external heat. On the surface, Mercury and Venus are the hottest planets, since they are closer to the Sun. But the core of the Earth is actually hotter than the surface of the Sun, while the core of Mercury is not much hotter than its surface. Because of this, it's basically geologically dead. Its surface is covered in craters, since there's no erosion or plate tectonics to clean up the surface, due to its lack of atmosphere and internal heat. Same story with our moon. Once upon a time, the moon's surface was active with lava flows, forming those dark seas we see on the surface. But billions of years ago, everything cooled off and dried up. So the moon is now just a big rock covered in craters. The Earth's internal heat gives us all kinds of other benefits. The spinning core generates a planet-wide magnetic field that can deflect electrically charged plasma ejected from the sun. That stuff would be pretty harmful to us if it got to the ground. But our magnetic field deflects a good portion of it, and our atmosphere protects us from the rest. Magnets always have 2 poles, a north pole and a south pole, where the magnetic field is strongest. This causes a lot of those charged particles to fall into the poles. This creates quite a light show for those who live at high latitudes. The aurora borealis, or australis in the southern hemisphere, aka the northern or southern lights, is caused by fast-moving particles from the sun ionizing the atmosphere, causing it to glow, the same process that lights up neon signs. Different colors come from the different elements in the atmosphere, such as nitrogen and oxygen.